everyone, and today I'm covering this extremely dangerous event that is currently playing out in the central to eastern United States on this Tuesday and Wednesday, and this is pretty concerning. Originally it wasn't too concerning. We might have gotten a few storms in the radar, possibly. We might have possibly gonna see some storms. That's what our perspective was originally, but now we think that pretty severe storms are going to fire, and definitely some tornadoes, which is very unfortunate. It's taken a turn for the worst. But why exactly did this change? Like, how did it change so quickly? Well, there's a reason for that. Let me get to that. So there's something I need to introduce to you, and that's CAPE. What is CAPE? Well, CAPE is convective variable potential energy. Basically what it is the fuel, the energy for storms. That's what storms feed off of, basically how they become so powerful. And there's two kinds of CAPE. One, there's CAPE that is uncapped, which is the CAPE that builds storms, which is the CAPE that we're seeing, the CAPE that better builds storm. And uncapped basically means that a perfect transition exists between cold and warm air in the atmosphere. In the air, at the bottom, there's warm air. And there's a perfect transition, a gradual transition, all the way up to the top of the atmosphere where the air is cold. That's how storms form, if it's a gradual transition between warm and cold throughout the atmosphere. And that is what helps storms build their structure, move farther into the sky. Then we also have capped CAPE. Basically, capped CAPE, when something is capped, it's not a perfect gradient between the warm and cold air. There is an interruption in between where we're near that sector where it is transitioning from warm to cold. We have a large warm bubble that is blocking the warming air from the colding air. And that is what makes things cap. It's like a cap. It prevents something from going through. It prevents the storms from building up with that gradual gradient. So, that was originally what we were expecting for the storm, and that's why we didn't think storms were going to build up because of that cap that was possible. However, that cap hasn't developed. We actually do have a perfect transition between heat and cold, which we originally were not expecting. So, that's why it's taken a turn for the worst. Here is a map of what that cap might look like. Now, these less faded parts, these little blurry parts, that's where it is capped. These non-faded parts, these clear areas, are where it is uncapped, where there is a perfect transition between heat and cold. So as we move this forward, this is around now, 4 p.m., and as we move on, this is the HRRR model, you can see that a huge change occurs because we have lots of energy here. This is very good CAPE, and if we take a sounding from here, oh, I guess I can't do it on this, my bad, but this is very good CAPE. This is good for storms. Storms can feed off of this amount of energy, and this is up to 2,200 joules per kilogram, all the way up here to Chicago. There's areas of 2,700 joules per kilogram, which, just so you know, is pretty good for any storm potential. That really helps storms develop, this amount of CAPE. And even in the main, not even in the main hot spots, there's around 1,000, 1,500 joules per kilogram, but realize right now, it's only a small area that is uncapped. That doesn't last for long, though. As you see, this area down here also begins to maybe see some small uncapping, but actually, the main reason why these storms are developing down there is because even without the cap, there's still a lot of energy. Tornadoes don't have to form if there is a perfect gradient all the time. Sometimes they can form without it. Because, I mean, it's not too hard to create a tornado. It is. You do need a perfect balance, but it's a little easier than some may think. But that's only the weaker tornadoes that would develop in that. Now, one thing I'm going to tell you, I think the HRRR model is kind of wrong. Why? Well, let's look at the NAM instead. You see how this whole line is uncapped? That is what we're expecting. That is what we're expecting since the cap hasn't developed yet. The HRRR is kind of outdated. This is at around 1 a.m. You can see there's a huge area where there's loss of energy and a perfect transition between heat and cold, which is absolutely perfect for tornadoes, strong tornadoes possibly, to develop. It is also good for hail to develop because hail also forms when storms build up. So we're also expecting extremely large hail, baseball-size hail, which is the same size as a baseball, which could definitely damage windows and your house probably. You have to be extremely careful in this storm. But the NAM definitely shows something different. It shows that the cap is completely broken, which is what we're seeing so far. Now, which one does the SPC think? Which one does the SPC agree with? SPC is the main group that decides what severe weather we're going to see. Well, let's get to this. Here is what the SPC thinks. So, let's look at the SPC products. And there you can see we have 2 enhanced risks, which are level 3 out of 5, which means it's halfway there from the smallest severe weather to the most extreme severe weather. There's one area down here in the Ohio River Valley between Illinois, Indiana, Ohio, and parts of Missouri, and also includes Louisville, Kentucky, and Evansville, Indiana. And this is driven by hail, which I already told you was going to be very dangerous, especially in this northern enhanced risk near Chicago. There was going to be some extreme hail that we're going to see. And you might be confused on what this dotted line means. Basically, this dotted line means that it's going to be that huge hail, not just the smaller hail, the huge hail, the baseball-sized hail. But it's not just hail. Of course, there's wind, which is actually the main risk for the southern area near Louisville, Kentucky, and Evansville, Indiana. There might be some very heavy winds that you'll notice, and this is also in a dotted line area, which basically means that those winds will be extremely strong. We might see up to 70, 80 mile per hour wind gusts, maybe a little less, but you definitely get the picture that it's going to be intense winds. But everything goes to this. This is the tornado risk. Now, these are lower numbers. You can see only 2%, 5%, and 10%. Basically, what this means, within a 25-mile radius, in a circle, a 25-mile circle of a given point, there is a 10% chance that that area will see a tornado. Usually, that chance is 0%. The fact that it's 10% is incredibly concerning. Also, if you multiply that to 250%, 250 miles, you may get 100% chance of a tornado in 250 miles. Now, that is not always the case. I'm not going to say there's definitely going to be a tornado in a 250-mile area. This is still possible that this doesn't happen. And plus, also 100% chance, it's not going to be 100% chance. It's always not going to be 100% chance. It's going to be more like 90%. That's not how percentages work. I mean, it's always possible that this doesn't fire, the cap doesn't break, like the HRRR was saying. But now you get the picture that this is really agreeing with the NAM model, because the tornadoes can only form strong tornadoes. Of course, this dotted line means very strong tornadoes, EF2+, that tornadoes could develop in an uncapped environment. That's what the NAM is saying. And the SPC agrees with them, which is, they had a choice. They could either do the HRRR or the NAM. But since they chose the NAM, that is incredibly concerning. So let's look at the models for this. Let's look at what exactly we're looking at here. What exactly are we seeing? Well, first let's look at the NAM, at the HRRR, which I know I said wasn't that good because it wasn't showing the cap wasn't breaking, but they still do show some stuff to note. First of all, you do still see supercells. One lone supercell near Mount Pleasant, Iowa, that develops and will continue to move along into Illinois. This is where that northern tornado risk develops, because there's a group of supercells here, supercells which usually create tornadoes, those large storms that build up all the way into the sky, and those are likely to put down some tornadoes, and even strong tornadoes in that area that is hatched. This is around 8 p.m., and they reach Chicago, and this is where they're probably going to be most likely to produce some tornadoes. But then, you notice a few storms are developing down here, which is where we'll get our southern risk. Our southern risk will develop from some of these storms that are developing around 8 and 9 p.m. South of Indianapolis, near Jasper, Indiana, you're going to see 2 supercells, possibly. Of course, none of this is impossible, but none of this is going to happen either. It's going to change a little bit, no matter how close you are. No models are perfectly right. But still, you might see some supercells near Jasper, Indiana at around 9 p.m. and more supercells heading back here into Missouri near Cape Girardeau and down towards St. Louis even. Then if you move forward, you get to 10 p.m. and even more supercells develop in that uncapped environment, which for some reason the HRRR is saying won't happen, but it's still showing some supercells that may produce tornadoes here. So that is definitely something strange to note. Now, let's check on this northern risk. This northern risk is causing some supercells over the Great Lakes now, which could produce waterspouts, but they're entering out of that uncapped environment. So that means that they're less likely to produce tornadoes. And that's why we don't have a high risk up here. We still have a 5% or 2% risk, because it's still possible we're going to see some supercells, but the tornado threat in this northern area is basically done. We saw it briefly here, and now it's done. The southern threat continues, though, as this new line of storms develops near midnight, and this goes through Mount Vernon, Illinois, Effingham, Illinois, up towards Vincennes, Indiana, and all the way there towards Louisville, which is where the main tornado threat is. And that is what we're seeing. We're seeing these supercellular storms that might produce some tornadoes. And if you look at this one closely, you see this little structure here? That kind of looks like a hook echo. A hook echo is a clear sign of a possible tornado on the ground. Just because it's like a curve in a supercell, that's where the inflow and outflow is coming in. The inflow is coming in, and the outflow is going out. That's a rotation. That's a rotation. Because, of course, rotation is developed by spin in the air. And if this area is spinning, it looks like a spiral, then that means that a tornado is there. Usually, it develops down here. So, we may see a tornado there. Of course, once again, this is not going to happen. It's going to change a little bit, but, you know, it is possible. So, we still have a tornado threat all the way into 2 a.m. possibly. Look at this. This is actually where the main activity might be in this southern risk. You can see a ton of supercells along this huge line, which is the frontal system. That is the frontal boundary between warm and cold air. Now, that is actually less likely to develop tornadoes, but it still can. It still is possible it will develop tornadoes. And this might not even be the frontal line. The frontal line could be back here as well. We're not really sure yet. It's a little messy at the moment, but it seems like these storms are still going to be able to produce supercells and tornadoes all the way through the night. All the way through the night into Ohio, Kentucky, all the way down the Ohio River into the Tennessee River Valley and the Mississippi River Valley, down into Jonesboro, Arkansas, and up there into Dyersburg, Tennessee. You can see some supercells are developing all the way down here, which we weren't really expecting much of a risk for, but the HRRR model is showing that supercells will be developed all along this line. Of course, this linear system will be less likely to produce tornadoes, but it's still possible, as you can see with these systems looking supercellular. This continues and continues until 6 a.m. 6 a.m., everything congeals into a line, and you can see nothing looks supercellular anymore. Now the risk actually kind of changes to another location. So let's look into the mid-Atlantic and the Northeast. This is where the main risk is now. And you can see some storms are entering into the mid-Atlantic, but they're definitely not what they were before. Maybe a few supercells here in West Virginia, and we actually do have a threat for that, a marginal risk, which is 1 out of 5, and a 2% tornado risk in 25 miles for that risk tomorrow. But this is less likely. Some supercells may be able to get out of the line, like here in Kentucky, but we're not expecting as much of a threat. It's more conditional, because this linear system kind of ruins everything. But this is going to cause some major winds. This is definitely going to cause some intense winds all across this area, all the way down to Tupelo, Mississippi, all the way up, where we have this marginal risk here, into Plattsburgh, New York, which is pretty surprising. This line is very wide-reaching, although a lot of these linear systems are wide-reaching. So that's the end of the HRRR model. But as we go into the NAM, it shows something fairly similar. Of course, this is a little less resolution. I think it's not doing the NAM 3 kilometer. Let's go to the NAM 3 kilometer on the Tropical Tidbits. Here it is. So we are going to look into the Midwest, the north central U.S., and you can see some storms develop here in Cincinnati at around 4 p.m., and they move off towards the Ohio River Valley. That doesn't look as much as a tornado threat. That could be some hail and wind, though. We could possibly be seeing some hail and wind with that, because it is still in that uncapped environment, realize, or at least close to the uncapped environment. Once again, we see these storms fire off. This is a little more congealed into a line, but I still think tornadoes are likely here because it's not one of those huge lines that passes all over the country. It's just a small cluster of supercells, which, even though they're feeding off of the same energy, which means they'll steal some of the energy from each other, it's still going to be so much energy where they'll each have enough energy for themselves and possibly produce some tornadoes near 9 p.m. Then we have that southern risk develop. You can see with these supercells that develop near Vincennes, Indiana, and down towards Mount Vernon, Illinois. You can definitely see some supercells are developing in the region, and even back here towards St. Louis, where this linear system is, there is still going to be a threat for tornadoes, QLCS tornadoes. The tornadoes that form along a linear system. And this is where the main southern risk is going to be. We're going to look down here for a little bit longer, and of course these storms strengthen just as they did in the HRRR model, which is surprising because the HRRR model is saying that it won't be capped, will be capped. But we can see still many systems are looking in the shadows here at around 2 a.m. and are producing some tornadoes possibly down here towards Louisville. So we still will see this, and it stops once again at around the same time. You can still see it's still kind of supercellular by 4 a.m., but it kind of merges into a line, which a line doesn't really help tornadoes to exist because every single system is feeding off of the same energy. Tornadoes are still possible, as I said in the risks tomorrow, because there is a 2% risk, and you can see these still look supercellular, so they could possibly produce tornadoes here in eastern Kentucky into West Virginia, and this is around 10 a.m., 11 a.m., but everything just becomes so messy at around 2 p.m., so that's when we're not really going to be expecting any tornadoes, which is something we should be thankful for, and we are not expecting any tornadoes in the Northeast. But then, what's this blue stuff back here? It may be hard to imagine, but that's snow. Snow can still exist in February, yes. So, you're going to see some very heavy snow, possibly in northern Minnesota into Ontario, definitely. Canada experiences lots of snow this time. But even some small snow showers from here in Nebraska, Iowa, into Minnesota, southern Minnesota that is, and into western Wisconsin. And even heavy at times, possibly up here to Houghton, Michigan, and down here into Wausau, Wisconsin. We're still going to see some snow, and this definitely can get pretty heavy. Actually, the thunderstorms may be so close to the snow there might be thunder with snow. Isn't that crazy? But we're not sure if that's going to happen. That would be called thunder snow. We're not sure if that's going to happen. But you can see over here near Green Bay, there was pretty heavy snow falling at around 4 a.m. as the severe storms continue along the Ohio River Valley, only 200 miles apart, so that's very interesting to note. And these snow showers will continue, maybe reaching their peak here near Traverse City, Michigan, and then we continue as the snow starts to calm down and moves all the way into Canada at around 5, maybe not 5 p.m., 2 p.m. So that's what we're looking at. We're seeing some snow in the mountains here in West Virginia. I can show the HRRR too, but really it's just going to say the same thing about the snow part. I believe it is anyways. Let's look at it. Here we have the HRRR anyways. You can see it doesn't actually show any snow. It just shows the moisture. But you can see this would be snow on the backside that we're expecting. So, lastly, we're going to look how much snow this is. How much snow we're looking at. And let's see a general accumulation of the snowfall. You can see general 2 to 3 inches here near Green Bay. And up into the upper peninsula of Michigan, which usually sees a lot of snow, we have up to 5 inches, which is pretty surprising for the storm because it is in a lot of warm air. Then up into Canada, we have 8 inches, obviously. However, down into New York, we still experience some snow, up to 5 inches near Syracuse, which is because of the lake effect, of course. And then we move into the Northeast, there's around 2 to 3 inches of snow. One thing to really note, the snow is not going to be the main part of this, obviously. The main part is going to be the tornado risk. But we're still looking at some snow, and it's still something to note in these northern areas where you're not going to be experiencing severe weather. So, that's about it, but what happens after? Well, let's look at the GFS model and see what's happening here. Over here, you can see some snow. The system, very strong system I might add, continues past the north coast. And then you can see another system forms and creates some moisture down here in the deep south, which may actually lead to some more thunderstorms, not exactly in the same areas, but south of those areas in Mississippi and Louisiana. Some of them may be severe, but we can't really talk about the storm yet because we're still focusing on the other storm. This is around Friday, Saturday. We might see some storms with these. But then this moves off the east coast and produces some rain along the mid-Atlantic. And then you can see another system, a very far northern system I might have, that's part of the polar jet stream, which is the jet stream that's all the way up here. This is going to cause some snow down into Traverse City in the same areas that experienced snow last time, but not going to cause too much severe weather. Then, interestingly, next Wednesday into next Thursday, you do have this system, which looks very interesting, looks very strong, and does have some of those parameters for severe weather down here along the Gulf Coast again. And up there into Georgia, you could see some. So that is another interesting system, but we can't focus on that yet because we still have to get through this first one. Now, one more thing I want to show you, just one more thing, is the upper levels. Why am I showing you the upper levels? Well, it's kind of necessary because this shows how much winds are in the atmosphere and how, since there's more winds, that means there's more winds to spin and create tornadoes. So, you can see, there is a ton of vorticity, which means a ton of spin. Up here, which is not where the moisture is, but into here, there is some moisture. And all the way into there is some moisture too. But you can see a lot of vorticity comes with this. And it is a little bit in those areas where those supercells develop. But that's not the main thing we can use. Here, we have to use the 850 millibar height and wind. And you can see, this is insane winds in the lower levels of the atmosphere. But still, that is potential for some tornadoes. Especially with these extremely strong winds in the southern area and the northern area to some extent. That is definitely some very strong winds. And that is what mainly people are talking about. Because these winds could cause some definite tornadoes, which we're hoping doesn't occur. but it's pretty inevitable at this point. Still is a conditional risk. It still could not happen, but with this cap breaking, it seems a very unfortunate situation, folks. But that's enough for now. Anyways, guys, I hope you liked this video. Please make sure to subscribe, turn on notifications. If you don't know what the notifications look like, it's a bell icon right next to the subscribe button. And also make sure to like this video. I don't care if you dislike. If you really didn't like this video, fine, dislike. I am going to attempt to be live. I think I'm going to fail because YouTube does not let me be live, but I am going to attempt. So, you may see me later, you may not. You'll see. Anyways, it's always better to just ride along. Always better to exit onto the Morning's Data on the Road freeway. Goodbye, guys.